To look at this question related to a Poisson random variable. We're told the number of accidents in a production facility have the Poisson distribution with a mean of 2.6 per month. And then we want to answer some probability questions related to it. The first thing is to identify a random variable. So let's say, let the random variable x denote the number of accidents. So we're just defining a random variable, the number of accidents in a production facility in a month. So let's define a random variable first. So we've defined it from here. So the number of accidents, right? So this is our x. The number of accidents in a production facility, right? So this is our x. Okay. So now we're told that x follows a Poisson distribution. And we know it only has one parameter, which is its mean, which is given to us as 2.6, right? Now we know that Poisson random variable takes on non-negative integer values, right? So it takes on values 0, 1, 2, 3, and so on and on. So it takes on non-negative because it can also take a value 0, non-negative, so it can take a value 0 or positive integers. Non-negative integer values, right? Now this is important. We'll see in part A and B why. It's always you should always note what values does random variable take on. You should always keep in mind, and we'll look at why in part A and B, right? So you should always keep in mind what value can a random variable take on, right? So this is something that should always be in our mind. Let's look at part A. For a given month, what is the probability there'll be fewer than 2 accidents? So we want to find the probability that where x denotes the number of accidents, so that is less than 2. Over here, obviously now probability x is less than 2. We need to know what values does it take on, right? We need to know this, right? We need to know what values does it take on for me to know what values come in x is less than 2, right? Because obviously if you don't know what values it takes on, how would we know what values of x are less than 2, right? So that's why it's important to keep in mind what values does it take on so that we can identify x less than 2 would include which values. Now we know whenever we're given the the PM, the PMF of a discrete random variable, we can find any probability regarding the discrete random variable by just summing up the PMF over those values of the discrete random variable. For example, in this case, if I want to find probability x is less than 2, x takes value starting from 0 to infinity, so on. So x less than 2 would mean just that x could be 0 or x could be 1, right? So we could just sum up probability x is 0 plus probability x is 1, right? This is how we can find probabilities of a discrete random variable from its PMF. You can just sum up the PMF over the values of the discrete random variables that you want. In this case, we want x to be less than 2, which we know means x is 0 or x is 1, right? So we can just sum up the PMF over these values, probability x is 0 plus probability x is 1. Let's try to understand why this summation works, the logic behind it. Probability x is less than 2 means probability x is 0 or x is 1. Again, for me to identify x less than 2 only means that x is 0, x is 1. We need to know what values does the random variable take on, right? So that we know, okay, less than 2 can only mean 0 or 1. Now, here, or means union. That's something that we should keep in mind. Or means union. So we can write this as probability x is 0 union x is 1. Now, here's something you should keep in mind. Okay, a random variable taking on different values are mutually exclusive events, right? So x is equal to 0 and x is equal to 1 are two mutually exclusive events because when you perform a random experiment, you can only get a single outcome, right? And then you only get a single value, the random variable corresponding to that outcome, right? So if you perform a random experiment, you would either get x is 0 or you would get x is 1. You can't have both of them at the same time. So these are mutually exclusive events. And because they're mutually exclusive events, we know the probability of the union is the sum of the individual probabilities, right? Random variable taking on different individual values are mutually exclusive events. So the sum of the union is the, so the union is the sum of the individual probability. So this is why the summation thing works. This is the logic behind it, since mutually exclusive, right? So this is the logic why when we are finding the probabilities of a discrete random variable using its PMF, we can just sum up the PMF over those values of discrete random variable. So this is why probability x is less than 2 can be found as probability x is 0 plus probability x is 1, right? So this is something that we know, right? When you're finding the probability, we can just add them up like this. But why? So this is the logic behind it. So now probability x is 0 plus probability x is 1. We want to find that. Okay. Let's just clear all of this and so we have probability x is less than 2 is the probability x is 0. Let me just quickly write this here. X is on mean is 2.6 and x takes values. Again, this is very important to keep in mind what values it takes. Probability x is 0 plus probability x is 1. So here, let's recall something. So for this, let's recall the PMF of a Poisson random variable. So in general, the PMF is this: probability x is k is e minus lambda power k by k factorial. In this case, we know lambda is 2.6. This is lambda, right? Because the lambda is essentially the mean value of the Poisson random variable, which is its parameter. In this case, lambda, which is a parameter of the Poisson random variable, which is equal to its mean, this value is equal to 2.6, right? So I can write this as probability x is k is equal to e minus 2.6, 2.6 power k divided by k factorial. So now let's use this to find the probability x is 0. For x is equal to 0, just put k 0. So this will be e minus 2.6, 2.6 power 0 by 0 factorial. For x, probability x is equal to 1, just put k is equal to 1 in this. So e minus 2.6, so then this becomes 2.6 power 1 divided by 1 factorial. And this will turn out to be 0.27. Right. Okay, so okay, let's do the next part, part B. I'm not gonna delete this. We will need this, so let's keep this part. Let's do part B. For a given month, what is the probability there will be more than 3 accidents? Probability x is greater than 3. So this is what we want to find, right? So probability x is greater than 3. So now we know, okay, if we were to do it as it is, right? So we know this is the probability x is 4 or 5 or 6 or so 7 or so on, right? This never ends because this takes value starting from 0, 1, 2 till infinity, right? So obviously we can't add that many terms. So we'll use the complement rule because then we'll be able to convert. So then in that case, we won't have an infinite number of terms. We'll just have finite number of terms, right? Because obviously x is greater than 3 means that x is 4 or x is 5 or x is 6 and so on, right? This keeps on going, right? Because it takes all non-negative integer values, and obviously this would involve like adding infinite terms. But if we use the complement rule, then we can convert this into a question of just adding a finite number of terms. So here we should use the complement rule. Here complement rule becomes relevant, so we'll use the complement rule here. So complement rule, right? Because then we can, instead of adding an infinite number of terms, we can just add a finite number of terms, right? Complement rule, probability of A is 1 minus probability not A, right? So probability x is greater than 3 is 1 minus probability x is less than equal to 3, right? So Poisson random variable, typically when you see probability x is greater than A, x is greater than equal to A, you want to use the complement rule because instead of adding an infinite number of terms, then you will just be adding a finite number of terms. So now probability x is less than equal to 3. Again, we need to know what values can this random variable take on to identify what values to include in this. We know it takes on these values, right? And so on. Right, so we know from here that probability x is less than equal to 3. X is less than equal to 3 means x can be 0, it can be 1, it can be 2, it can be 3. So again, it is important to keep in mind the values a random variable takes on so we can identify which apply in our case, right? So we need to know if it takes values starting from 0, 1, 2, 3 and goes on to take all non-negative integer values to know that probability x is less than equal to 3 means that x is 0, sorry, minus probability x is 0 or x is 1 or x is 2 or x is 3. Right, so we need to know that. And like we said, we're just trying to understand why we can do the summation. Otherwise, we know probability x is less than equal to 3 would mean probability x is 0 plus probability x is 1 plus probability x is 2 plus probability x is 3, right? Because when you want to find any probability of a discrete random variable using its PMF, you can just sum up the PMF for those values. So we can just sum up the PMF for these values. But we know why the logic works. We know, okay, or means, we're just trying to understand the logic behind it. So this is, we know, or means union. So then this just becomes, if you want to do it showing the entire logic, 0 union x is 1, union x is 2, union x is 3, right? And then we know, okay, because all of these are mutually exclusive events, like random variable taking on different individual values, So it's just the sum of these individual probabilities because they're mutually exclusive events, right? We could have done this directly, written this directly as well, but we're just trying to understand the underlying logic. Probability x is 3, right? ठीक है ना, right? So this is since mutually exclusive, right? So this is just the logic, although you could have written this directly as well, right? You could have just written this directly, right? Okay, probability x is less than equal to 3 is the probability x is 0 plus 1 plus probability x is 2 plus probability x is 3, but this is the logic why we can add them like this. Okay, so probability x is equal to 0 plus probability x is equal to 1 we already found in part 1. That was part 1 that we found, so just use the answer from part 1, 0.27. Right, so this was from part A. From part A. So let's find the probability x is 2. So we know this is the PMF of a Poisson random variable in this case. So probability x is equal to 2, just plug in k instead of k2 over here, right? So it becomes e minus 2.6, and this becomes 2.6 power 2 divided by 2 factorial. And for probability x is 3, just plug in instead of k3 here, right? So this becomes e minus 2.6 into 2.6 power 3 divided by 3 factorial, right? So once you have the PMF for this specific case, and just plug it in. And then you can just solve this, and this will turn out to be 0.26, right? So in this way, you can solve this. So this is how we can solve this question related to this. So just keep in mind, it's always important to keep in mind the values it takes, right? The first thing you should always note is the values of this random variable can take for. So because for me to identify what probability x is less than equal to 3, what values to include in that, right? We saw, okay, for that we need to know what values it takes. For me to know probability x less than equal to 3 means that x could be 0 or 1 or 2 or 3. We need to know what values it takes to identify this, right? And then obviously we know, okay, we can always sum up the PMF. Like if you want to find any probability using the PMF, we can just sum up the PMF over those values like we did over here. Like probability x less than equal to 3 is probability x is 0 plus probability x is 1 plus probability x is 2 plus probability x is 3. But we try to understand the logic behind this in these two steps, right? Like why this addition in this way works, like why we can go from here to here, right? The logic behind it is these two steps.